方便的话就看是不是测试一下这样子。
哎，你知道我现在测吗？
可以啊。
哎，来，看一下。好，好久没用了。
打开有一个分享，
要知道有分享。
其他这边点开有一个哎不对，离开的旁边有一个分享，然后选择您要播放的投影片的那
哦，
个，
有。
对，视窗就可以，然后就会看到。OK，
这样
这样是
看到吗？
有，
看到我全屏幕上面的东西，
对
对不对
对
？OK，
对
这样全部看到嘛，对不对
对，这样全部看得到。
？OK，
对，
stop sharing。啊，我都要几点钟要出现？
2:50，因为你等于
2:50。
都 test 好了，您可以线上就等我们一下下没关系，然后可
有
以先 off screen 没关系，然后
有多少人注
就是
册？
啊，
有多少人会
报名
上？
70多个。
哇，有报名这么多人啊！OK，
对啊，我们
我没有看
大概
到
对
agenda，
不起对不起
我没有看到 agenda，agenda 就是
，agenda 那个敏慧你 share 一下 agenda 好吗？
好，等我一下哦。
谢谢。
哎，有看到吗？
没有，只看到
也有
你。
直播，那个有那个 Stewart 已经上线了，我们现在已经在测
我现在
了。
看到
OK，
了，
谢谢，
看到了，现在
是谢
看到你。
谢谢谢，拜。Judy 来电话确认一下你有没有上线。
他很负责。
是，谢谢，
哎，对，我今天有点感冒。
没关系，take it easy。
OK，
好，感谢您，时差调回来了。
我现在今天晚上要走啊，
好，又要飞出去，辛苦了辛苦了。
今天晚上要飞出去。
OK，您的那个可能镜头要稍微调一下，就
嗯，
是您这样子，
我知道，我知道。
OK，这样没问题，是不好意思。
我现在只是我在吃东西，不要看了。
Sorry。
好，
谢谢啊，
那我就先暂时等一下了。OK。
好，麻烦您，谢谢。那就我们这边先把您这边也先暂时设静音，等一下那个会议开始再打开。谢谢您，
可以。
谢谢。
吴董你好。
吴董现在正在用餐，我们刚刚已经有跟他说过话了，对过了。
哦，好，谢谢你们。
好，
谢谢。
你好啊，对不起，我上来了。对，
不会，吴董，不好意思，今天麻烦你了，谢谢。
没事，好，谢谢。
好，谢谢吴董。咱们这里有个外国人呢。
这是我们邀请的讲师吗？
那个是 Martin 他们那边的，不是 Martin，那个 Thomas 那边的人。
Thomas，
你是说 Sony Lab 吗？
是 Sony Lab 的人，对。
那你要让他先进来吗？
但是他不是讲师哦，是 Charles 他是讲师。
我是觉得外国的可以先让他进来，没关系啊。因为我怕他等太久，会以为就没上就
没有
了。
好啊，那我们就先让那个，因为他是我的那个讲师名单，我是统一发了，因为他们加一次要4个人，我们就让他先进来哦，哈。
好，
先跟他打招呼。
哎 ，Hello。
那个任伟进来了。
Jaffer。
Hello, yeah, hi.
Hi.
Good morning.
Hi, morning.
Good
So,
afternoon.
Jaffer, today's workshop, you will say something on the workshop or only Charles?
No, I think only Charles is going to be presenting.
Oh, okay, thank you. Got it.
So I think I can drop off now and join at 8. Is that correct?
Yes. This timeline is for speaker to test their PowerPoint and their voice, but you can stay online. Is no problem.
Okay.
Yeah. Hi, Abdel.
Hi. Good afternoon.
Hi, 任伟。Hi。
能听到我声音吗？
可以。
OK。
You can hear me all right, right?
Yes, your voice is clear.
I can hear you. Yeah.
Yeah. So,
Simon, 你有点小声。
等我一下。
Okay, I'll switch off the camera for now, and then I'll be back after.
Yeah. Do you mind to stay a little bit to check your slide presentation? Is okay?
Yeah. Okay. Yeah. Okay.
Okay. Thank you. So we are going to let every speaker to present their own slide, and so Abdel, if you want to leave for a while, so how about share your slide first, and let's check if it works well.
Okay. 1 minute then. Give me a second. I bring it up.
Hi, Charles. This is Simon. So we are now waiting for Adele to share his slide, and maybe you can give us some word so to test your voice. Your video looks good, and you are next to test about to share your slide.
Okay. Can
Thank
you hear
you.
me okay?
Yeah, your voice is good. Video
Okay,
also
excellent.
good. Thank you.
Excellent. Just
So,
let me know when it's time for me to walk through my slides. So we're all sharing our own slides from our.
yeah, from your own, yes.
Okay, I'll be just 1 minute.
Okay.
Yeah, okay, so let me share. Where's the share button? Here it go.
任伟跟伟明两位可以讲个话，测一下声音，谢谢。
Hello everyone.
Okay.
Hello.
OK，两位声音、影像都 OK，谢谢。
I'm trying to share. The button is not actually clicking at all.
Oh, really? So I think there's just share button.
Yeah, I can see it, but I press on it and nothing happens.
Oh, really?
Yeah.
So maybe you can try a little bit. And Charles, we can.
Yeah, maybe Charles, if you want to let me. I'll sign out and sign back again. I think it's a glitch on the software.
Okay. So Charles, it's your turn. Hi, Charles. Are you with me?
Slide.
Okay.
Can you hear me?
Charles?
Okay.
Charles, your mic is off.
Can you hear me now?
Oh, yeah, it's good.
Okay. I was sharing my screen, so let me share again.
Yes, please.
Can you see my slides?
Not yet.
Can you see the slides?
We are still waiting. Ray，你那边有看到那个 Charles 的 slide 吗？
Can you see the slides?
Still waiting.
Okay, so I think how about this way? Minghui will help to share your slide, and after you finish each page of your slide, you can tell her, and she will help to switch the slides. Is that okay?
Okay.
Sorry. Can you see my slides?
No, we are still waiting.
All right,
so we only see white screen. So that's why
let me try again. Can you see them now?
Not yet.
No?
No, not yet.
It's a very big delay.
Yeah. So
Yes.
how about we will share the slide for you, and you ask Minghui, you tell Minghui if you finish each of your slide. Is that okay?
Yes. Yeah, let's
Okay.
do that. So share from your side. Let's see. I'm very surprised that the delay is almost a minute,
Yeah.
even more than a minute.
Yeah.
Yeah.
敏慧，麻烦你一下，
好，等我一下哦。
谢谢。
Hi Charles, hi Ethan.
Hi, Dave. Hi, everyone.
敏慧，这是你投的嘛，对不对
对，我投的，
？OK，
有看到吗？
有。Hi Charles, do you see the slide?
No, I see a white screen.
Okay. I think that's the same as what we saw a little bit earlier.
But I
Does
see
someone
that
have to
slide.
give? Does someone have to give me the right to share?
I think we already give. Let me check.
Yeah, because
Yeah,
from your side.
you already got authority.
Okay, then
Yeah.
on my side, I'm seeing just a white blank screen as well. I don't see anything.
Why? We are all good with your slide on the screen right now. So or maybe please you leave this meeting and come back to see if you can present good. Is that okay?
Yeah, let me do that now.
Okay, thank you. 那个 Okay, we got you, Abdel. We have your
Sorry.
slides.
Did I start sharing already? Okay, sorry.
Yeah, your slide is on the center of the screen. It's good.
Okay.
Yeah, you're changing and everything's good. Okay, thank you. You can turn off your video, your screen and your mic for a while, and we'll call you back later. Thank you. And 任伟，麻烦你。Oh, okay, sorry. Okay, Charles, are you sharing your slide?
Yes, I am.
Yeah, very good this time.
Okay, so you can see all the slides now.
Yes.
Okay, and you can hear me all right?
Yes, very good.
And you can see me all right?
You mean on the screen?
On the video?
Yes, very good.
Okay, so we're good.
Okay, very good. Thank you.
I'll stop sharing now.
Okay, thank you.
And then mute.
Thank you. 任伟，麻烦您。
Okay. Other movement. Did you see my slide?
有。
Okay.
Thank you.
因为我有个影片呢，我想要稍微让它动一下，这样可以看到它在动吗？
有
我大概会快速去穿插一过，这影片不会太久。我自己写的 code， 我只是要大概讲一下 Rick 的 decision making process。
OK。
好，可以动就好，没问题。其他应该都还好。
好，
应该没问题。
我们中文讲师的部分就是会分两段，前面是外籍的讲师先报告完 QA 完，然后中级的讲师，所以我们可以用中文分享。
那如果用英文分享也可以吗？还是我一定要跟你？
欢迎。欢迎。
好。
OK， 好，谢谢。
OK， 谢谢。
Simon 那个德国医生
有我看到了，
分享过，已经分享过。
This is Simon 他已经分享过了吗？
好像还没。
Hi, this is Simon. Sorry.
Simon,
first time to see you online. Nice to see you.
Yeah, nice to meet you as well.
Yeah. So, do you mind to your video and your sound is good? Do you mind to share your slide from your side?
Yeah.
And we can check if it works well.
Exactly. Give me a second, please.
Thank you.
Do you see my slide? And now I'm changing them.
Yes, very good.
Also, do you see them changing or?
Yes.
Okay, great.
Okay, thank you.
So I will share my slides basically myself, right? Because
Yes.
I provided this. Okay, right, great.
Yes, thank you. 伟明，接下来换你。
好，等一下哈。这样有吗？
有声音 OK， 你声音可能大声一点点。
好，我等一下大声一点。
OK， 好，谢谢。
怕太大声。
OK， 好，那秀荣，请问你有在线上吗？
有，我有在线上，我先
好，
看一
麻烦
下画面。
换你。好，谢谢。
好，那等我一下，我分享一下画面。请问看得到我的画面吗
OK， 声音跟影像都 OK， 谢谢。
谢谢。
瑞燕、华丽。
我应该不用，我没有投影片。
你没有投影片？好，
我就那个。
那这样
听得到我声音嘛？哈。
可以，声音 OK。我看一下你的影像，OK， 好，声音、影像都 OK。好，那hi every speaker, this is Simon. We are going to let the attendee to enter the meeting room from 1450. And you can see, you can turn on your video when you start your sharing. So let's wait for a while. And Minghui, please share the agenda of today's meeting from your side. Thank you.
请问是有听到背景音乐吗？
有，
好，
但你的投影片好像没有。
我知道
那个，对。
好，我把它放开了。
Hi everyone, this is Simon from E3. Welcome to join today's online workshop. We are going to have the workshop start at 3 o'clock in the afternoon Taiwan time. So please wait online for a while, and please pay attention after joining the meeting. Please turn off your mic to make the workshop work well. Thanks for your help. Thank you. 各位与会先进，大家好，感谢大家今天参加本场开放架构伙伴平台工作坊。我们的会议将在3点开始，请大家稍待，谢谢。Hi everyone, this is Simon from E3. Welcome to join today's workshop, and the workshop will begin from Ray Chang, Deputy Manager from E3. So let's welcome Ray for the beginning.
Hi, can you hear me?
Yes.
Yes. Okay. Thank you. 各位先进，大家好，我是工研院那个张瑞燕副理哈，主要是负责TIP 实验室5G 验测平台的运作哈。那非常感谢大家参加本次产发署所举办的这个工作坊的活动。那目前5G 验测平台已经协助国内厂商大概30家厂商69家次的这个验测活动那也并协助其中11家的厂商获得国际的这个 TIP 标章那非常感谢各位厂商的参与那我们也希望借助这样的助力台厂打入国际的这供应链。那随着全球的这个5G 的这个技术的这个蓬勃发展特别是在专网或开放网络的这些推动那以及人工智慧这一块的崭新的应用。那为了积极应对新兴的这些国际的发展趋势那产发署所成立的这个验测平台会将持续协助台厂掌握国际商务的这个发展的契机那与台厂共同推进这个加速与国际的这个接轨那我们本次工作坊很荣幸邀请到英国的 Sony Lab 的 Charles 他 take lead 然后 Fraunhofer 的 HHI 的 Ethan the Head of Modular Network Group 以及 TIP 的 Abdel 经理以及国内的伙伴 MIC 的张仁伟分析师还有易传的 吴文灿董事长以及工研院的专家等来跟大家分享互通网络迈向节能的通讯，以及 TIP 的测试策略RIC 的发展的趋势，以及5G ORU SOC 整合的这个 solution 的这方案等那我希望透过国内外的专家的实务的分享促进国内的更了解国际市场技术开发这样。好。Greeting to our esteemed speakers and industry experts. I'm Ray from E3. Thank you for participating in the workshop today. The workshop is very honored to have Charles from Sony Lab and Ethan from Fraunhofer HHI and Adele from TIP and our domestic partners, analysts, Richard Zhang from MIC and Chairman Stuart Wu from Metanonia Communications and the experts from E3 to share the insight on Open RAN networks. Through the practical experience shared by domestic and international experts, hope to foster a deeper understanding of international market dynamics and technology development trends. Thank you again to our esteemed speakers and industry experts today, and we hope everyone will gain a fruitful experience from today's sharing sessions. Thank you.
Thank you.
Okay, now let's welcome Charles from Sonic Labs, and he will start to share his slide today. Now, the floor is yours, Charles.
Morning, everyone, and thank you for having me. Can you all hear and see my slides okay?
Yes, everything's good.
Yes. Okay, so as an introduction, my name is Charles Triagenda, and I am a Principal Technologist at Digital Catapult in the UK, and also the Technical Lead for the Sonic Labs program. I have a few minutes today to discuss two aspects of the Sonic Lab activities, but before that, I will start off by giving everybody a broad introduction into what Sonic Labs is and highlight the two activities that we have done on integration and interoperability testing in the previous cohort we had, as well as some of the Open RAN innovations in RIC that we conducted. So I'll start off by describing the Sonic Labs program, which stands for the Smart Open Network Interoperability Center. The Sonic Labs program started in 2020, and it's funded by the UK government's Department for Science, Innovation and Technology. It's a collaborative program between Digital Catapult and Ofcom. Ofcom is the UK regulator for telecommunications and all of media. And the primary focus of the Sonic Labs is to support the 5G supply chain diversification by taking early Open RAN products, integrating them into the lab, and then advancing the features of those components with a view of making them commercially ready for deployment into UK systems. So Sonic Labs is neutral. It's commercially neutral environment, so we do not support any particular vendor. We have got deep technical expertise in Sonic Labs that helps us to conduct these experiments. And we also have an ecosystem both locally within the UK as well as internationally that we work with to achieve our goals. At a very high level, these are the capabilities that Sonic Labs has got. The foundation of all of our work is our senior technical experts both in Open RAN as well as 3GPP and other telecommunications standards. We have got a large-scale outdoor deployment that is about 1.5 kilometers squared, and this is what we use for our outdoor field trials and tests. We've got an indoor Open RAN environment that has got 9 RUs and 3 DUs and 1 CU together with a RIC and SMO. And this is what we use for indoor deployment and indoor testing of Open RAN systems. We've got advanced test and measurement capability from the key test and measurement vendors in the world, namely Keysight, Viavi, Rhoda Schwartz and Aspirant. And then we have a private cloud platform, which is essentially a VMware cluster where we're able to deploy different virtualized Open RAN workloads, and this speeds up our ability to deploy and test the different Open RAN systems. In addition to the technical capability as well as the technical experts we have within the program, we have got a large ecosystem engagement, and this is through MNO working groups, the mobile network operator working groups within the UK. We've got a wireless infrastructure working group, again with UK companies as well as other Open RAN vendors. And we've got a testbed working group that we use to feed into our activities as Sonic Labs. Related to this workshop today is we also have an international working group, and we collaborate with E3 in Taiwan, NTIA in US, ENTC and I14Y in Germany, and CDOT in India. Moving on to the actual test sites that we've got, I will now present some small details about the indoor facility we've got. The indoor facility we've got is about 1,000 square meters, and it covers 2 floors within the Digital Catapult Sonic Labs. In here, we've got, as I mentioned, 9 RUs, 3 DUs, 1 CU, a RIC, and some core network from Druid. This is then connected into our server room, which is our main data center, private network data center. And that connects to our outdoor environment, which is in Hammersmith and Fulham, and that is made up of 7 microcells, 2 macrocells, and this provides a large-scale outdoor deployment. The microcells also are varied. We've got directional antennas on those microcells, as well as Omni antennas. The Sonic Lab is also interconnected to the Ofcom site, which is at Riverside House in the UK. And we've got a few Open RAN deployments over there, and all of those sites are interlinked with the 10 gig optical connections between the sites. And finally, the Sonic Labs is part of the Joiner program, which is the UK's initiative on federated hubs, federated telecommunication hubs in the entire UK. So it's not isolated, it's part of a wider UK network. Finally, I just want to show some images of some of the tests that we've conducted. We've got on the right the microsites and macrosites on our outdoor system, and some of our engineers conducting the field tests for some of the cohort activity that we conducted, as well as images of the server racks and the TM500 key from VRV that we use for testing. To this point, Sonic Labs has had several successes in terms of industry engagement. We have so far managed to sign MOUs with 3 international partners. We have got 3 industry working groups, 1 strategic advisory board meeting, and we work with all the 4 operators within the UK, and that is 3 EE, Vodafone, and VMO2. Up to this point, since 2021 up to now, we have had 5 cohorts, and the cohorts are our mechanism of testing Open RAN products. Each cohort has got a different theme, and today I will focus on the last cohort we've had, which is cohort 5, which was mainly testing Open RAN at scale. Through these cohorts and these engagements since 2021, we have so far engaged with vendors from across the globe. We have 26 vendors from across the globe. We've had over 150 strategic engagements. We have conducted 71 product tests under tests, and these are end-to-end systems. We have 3 MOUs signed, and we have collaborations with all the 4 UK operators. Some of the vendors that we have worked with in the past are listed on here. I can't mention all of them. Some of them are on this call, and we greatly appreciate your continued support and engagement with Sonic Labs. With that very high-level introduction into Sonic Labs, I will now focus on the two technical areas that we have covered in the last year. The first is the Sonic Labs Cohort 5, and this was conducted between April 2024 and February 2025. We are currently in the phase of Cohort 6, but we'll have another presentation for that at another time. Today, I will focus on Cohort 5. Cohort 5 had 7 vendors, and we had 12 products, and we integrated 17 end-to-end systems out of various combinations of these products. The theme and the aim of Cohort 5 was to evaluate Open Run at scale while validating aspects of performance, handover, and mobility. And for the first time, we conducted outdoor testing of some of these products on our outdoor test facility. The entire cohort was broken down into 3 stages. We had a staging stage, and we had an indoor testing stage, which included over-the-air testing as well as cable testing. And the final stage was the outdoor testing. The importance of having the indoor staging was to be able to conduct some initial tests on the outdoor areas in particular, so that we minimize the amount of time and debugging that we need to do on the outdoor site. I'll now present a few outcomes from the indoor testing as well as the outdoor field trials that we conducted. So some positive performance results came out of this. So for example, for the very first time, we had systems that achieved 85% of the maximum peak throughput, which to us is an indication of the performance maturity of these Open Run systems. In the field trials, we conducted throughput performance experiments in various radio conditions. For example, we had excellent, good, fair, and poor radio conditions, and we observed that the performance of the Open Run systems was still sufficient even within the poor conditions. So we've got performances of about 50 megabits per second in the uplink and 300 megabits per second in the downlink, even in the very poor conditions, which to us as Sonic Labs is an indication of the maturity of Open Run products to this point, considering the performance that we were achieving back in 2020 and 2021. In addition to outdoor performance, we also conducted scaling up of the number of UEs that are connected to the Open Run systems. And for this, we used mainly the UE emulators from Viavi, and we were able to scale up some of these systems to slightly over 500 connected UEs simultaneously, which again is a big step up from where we were with Open Run before. In addition to the cabled scaling up of the number of UEs, we also conducted field trials with multiple UEs. And for this, we were using the Keysight's Nemo backpack, where we had 12 devices connected at the same time. And again, we were able to produce quite decent throughput performances, both in the uplink as well as the downlink. So the key takeaway from this cohort 5 activity, which was evaluating Open Run at scale, the key takeaway is the performance of Open Run. It has improved significantly from 2021, and we're getting performances that are coming very, very close to the maximum theoretical maximums stipulated by 3GPP. The second aspect I would like to talk about is the Sonic Labs Technology Access Program, and this is a mechanism for us to test out new concepts within Open Run. In the last Technology Access Program, we had a consultation with all the mobile network operators within the UK on which aspects of Open Run they perceived to be most interesting or most innovative. Unanimously, they all came down to energy efficiency of Open Run, and we then structured our Technology Access Program to try and address energy efficiency of Open Run systems from 2 perspectives. And the first theme was to have RIC-enabled sleep modes to achieve energy efficiency. And this meant that we have to develop some XApps to run within the rig. And those XApps will trigger sleep modes depending on load conditions, etc. So that was one theme. And the second theme was monitoring and measuring the energy efficiency of the CPU cores of the servers on which the CUs and DUs run. And the objective of this was to try and work out whether we can optimize the configurations of the core servers on which the CUs and DUs run in order to improve the energy efficiency of Open RAN systems. In this technology access program, we had some very decent partners. Under the first theme that was developing the RIC applications, we had the University of York, ZTouch, and NetAI, who all developed different algorithms leveraging several AI ML techniques to achieve energy efficiency. In the second theme, we had Jet Connectivity and G-Rains from Taiwan, who put their CUs and DUs as systems under test to try and optimize the servers to improve the energy efficiency of the CU/DU software. I will quickly talk about the key results that we observed. So, sorry. Was there a question, or can I continue?
No, it's okay.
Okay.
Sorry.
All right. Sorry, someone interrupted me. Apologies. So under the RIC-enabled sleep mode for energy efficiency, we had varying performance of energy efficiencies ranging from about 5% to 13% energy efficiencies. And these were using AI algorithms. Some of them were using convolutional neural networks. Others were using SVN and several AI algorithms. The key takeaway from this theme was that we can achieve significant energy savings, as high as 13%. However, this energy savings come at a cost of reduced downlink throughput. Now, this may be acceptable in some networks, especially if the network is lightly loaded, but in other situations, it may not be acceptable. So the key takeaway is to bear in mind this trade-off between saving energy as well as balancing out the overall system throughput. Under the second theme, where we had G-Rains and Jet Engineering CUs, DUs, again, we observed a potential for significant energy savings. So, for example, under very low load conditions, if we performed certain configurations of C and P flags within the CU/DU server, we were able to achieve 25% energy saving. Now, this energy saving gradually decreases as the load in the system increases. And when we went to the very high and busy loads, we observed that we had very little or no savings at all. Again, this is an indication that there is potential to save energy under lightly loaded conditions. And that is the end of my presentation. Thank you all, and I'm happy to take questions.
Hi, Charles. We'll have this quick Q&A section after all three foreign speakers. So please wait online for a while, and we'll have Q&A hosted by Ray. And let's thanks again for your great sharing about cohort 5 and the program technology access program from Silent Labs. So please wait online for a while. And then let's welcome Ethan from Harvard HHI I-41 lab. He will share us about the topic toward green communication. Let's welcome Ethan. Ethan, the floor is yours.
Hi, thank you very much, Simon, for the nice introduction and invitation. I'm Ethan Twedy from Fraunhofer HHI in Berlin, Germany. So I would like to start with this question that why we want to look at energy efficiency. So in this figure, sorry, I just didn't ask, do you see my screen and the slides?
Yes, everything's good. Voice, video,
okay.
slide.
Perfect. Okay. So in this figure, I'm showing you the basically network data traffic over the last 7-8 years. And you can see that we are experiencing, let's say, around 21% growth over the last few years. And then on the other hand, on the right, what you can see is the electricity increase over the last few years, which is around 2-3%. So the question is, So the question is, now we are seeing a natural increase in energy efficiency, right? I mean, the rate of increase in data traffic is way faster than the electricity usage. So why we even want to look at energy efficiency anymore if we have this energy efficiency naturally in the system, in the network? And then the second point is that even though the network data traffic is still increasing, the rate of the growth is decreasing. So we are getting far from, I mean, if we see the trend over the last few years, it seems that we are getting far from this exponential growth. But if there is a catch here, right? I mean, if you look at the network OPEX of telecom operators, it turns out that 15% of the cost is basically associated with the electricity. So there is an importance of reduction of electricity consumption and providing energy efficiency in order to make them more sustainable. And also, yes, maybe so far there is a decline in the increase of the data traffic, but there seem to be some changes very soon coming. And it is because mainly new services that are introduced. And also, you know, we all know about this AI era and the explosion of generative AI use cases and so on and so forth. So I hope that it's clear for everyone that, yeah, we need to tackle this challenge of energy efficiency. Before continuing with with my presentation, I would like to introduce the digital twin, which we use as a tool for the studies that we have in the energy efficiency topic. So digital twin is essentially a digital representation of the real world. The underlying phenomenon can be an object, can be a framework, a process. And essentially you use the digital twin to be able to represent what is happening in the real world phenomenon. You can do optimization, so you can provide higher efficiency. You can predict the future, so you can be proactive, and also you can analyze what if scenarios. And it has already been investigated in several different domains. What we have done at Fraunhofer HHI in collaboration with some partners, and especially Deutsche Telekom, has been to develop this Open RAN digital twin. So on the bottom left, you can see this blue box, which is basically the core of this digital twin, Open RAN digital twin, which is based on the NS3, and it's an open source packet-based network simulator that due to open source nature of it, you can customize it, you can further develop the functionalities. And actually it already has also many libraries that one can use. Then we have this near real-time brick that we have developed X apps for different use cases and functionalities. The good thing about this near real-time brick that we have in this digital twin is that whatever X app you develop here, you can directly use it in your testbed. So in the in the real Open RAN testbed that you have eventually. So you can test what X app development you have in this digital twin, see the performance, and only when you are sure about the performance, you can run it in your real network. We have an S3 AI interface that allows us to run machine learning algorithms and in general optimization algorithms, and then eventually we can do the visualization. And then on the right bottom, basically we have this scenario generation box, which gives us a full flexibility in terms of generating scenarios that can be used to study different scenarios in a network. So we are very flexible in terms of using channel simulator, in terms of mobility simulator, and also generating different types of traffic models. All right, so I hope that you're convinced about why to optimize energy consumption. I would like to say a few words also about what to optimize when it comes to energy efficiency. So one very important factor is modeling. I have brought here a few illustrative models just to explain why it's important to understand the right model and why we need to put some effort in this basically aspect of the problem. So on this plot here, you can see an illustrative linear plot of energy consumption versus load. And it turns out that if you have such a behavior of energy consumption versus load, it doesn't matter how many elements are active or inactive. So the energy consumption is only basically a function of the total load that you have in the network. But as a second example, where we have an affine function with a big constant part of energy consumption, which means that as soon as you activate an element, even in an idle mode, so without no load, you will still have some energy consumption. And you will end up with such a behavior of energy consumption versus load. It turns out that keeping the minimum number of components active will lead us to reduce the energy consumption. And as a third example, we can see that in case of having a convex optimization, pattern of energy consumption versus load, keeping the minimum number of components active would reduce the energy consumption. So you can see with these three different examples of energy consumption model, the way to provide energy efficiency is completely different. And this basically means that we need to do a lot of energy consumption measurements in order to characterize models that capture the main characteristics of the energy consumption. And of course, the key messages here are that it's not only about, for instance, radiated energy, but also we have operating energy, meaning that as soon as you activate an element, you're using some energy. And then also this variety of components. So we have radiating elements, also processing elements that can have a totally different behavior when it comes to energy consumption. So there is a big need here to understand how different elements and components of network, especially considering the legacy components, behave in a network versus the load that we have. Another aspect that also Charles partially mentioned in his presentation is about the metric that we want to use for energy consumption. So it turns out that if you just want to minimize the sum transmit power, let's say condition and satisfying the user demand, it turns out that we will have all the base stations operating at full load and then the rest would be switched off. But of course, this is not acceptable for a network because it's not robust. And also if you have popping up a new users popping up, then you cannot serve them. So essentially, we are talking about a multi-objective optimization problem. It's not only about energy efficiency, but also spectral efficiency, latency, and reliability. And one needs to really look at this problem from this point of view, that there are several objectives, and usually they are actually conflicting. And this is why we also do this conflict mitigation studies in our work, and also in collaboration with I14Y projects and so on and so forth, to understand how to resolve such conflicting objectives that we would have. All right, so now let's talk about how to make the network more energy efficient. So far I just motivated at why we want to do energy efficiency and what to be optimized, but now let's talk about the methodologies. Of course, one can talk about the architecture in a network. So for instance, how you distribute the resources in an environment. And it turns out that if you want to scale up the network, of course, you need to have denser infrastructure deployment. And also we can talk about the active mode. So It means that when you want to serve the users, how do you do it? How do you exploit the number of users? How to optimize or exploit the diminishing return of the channel capacity? So to what extent you want to increase the transmitter power or increase the number of users, and at what point you want to make it denser, the deployment of the infrastructure. But actually, for the rest of the talk, what I would like to talk about is addressing this idle mode, or the so-called underutilized network resources. So it turns out, I mean, yeah, first of all, the purpose of the mobile networks are two things, right? I mean, one is the coverage. So you want to make sure that almost everywhere you have this connectivity. And second thing is about the capacity. So you want to provide high data rate demands for the users. But then it turns out that the traffic really varies a lot across time and location. And you can see here on the right figure in two different areas, urban and rural areas, over one day, 24 hours, that how much the traffic and the load of the network is changing. So it seems that there is an opportunity to, for instance, optimize the status of the network based on the traffic, right? Some load adaptive energy efficiency. So the question would be, can we just simply switch off unnecessary base station? Meaning that, yeah, when I see that there is a low demand on the network, I just switch off some elements. The problem is that it's not as easy as you think, right? And this is essentially for several reasons, but one of the main reason is that when you switch off an element, it takes some time to switch it off. But then also when you want to activate it again, you need to wait for some time to be activated again, right? And this is very dependent on the technology that we are talking about, the component, and also in the level of a sleep mode. So there are several sleep modes, I mean, from very deep sleep mode to shallow ones and so on and so forth, that will have different impact on this wake up time until the element and component is ready again. So basically, it means that with this delay constraint or wake up time, you need to be able to, well, this limits basically the weight or the amount that you can save energy. And for being able to exploit this variation in the traffic, as was mentioned in the previous slide, and considering this wake-up time, then we need to have load prediction. So we need to understand how the load behavior changes in the future, so we can predict it in time, so that we can activate the element in time. Otherwise, if we cannot do that properly, then we cannot switch it off, because otherwise it will end up with a big compromise for the quality of service. And this is one of our basically department studies, that it turns out that predicting the behavior of the traffic or the exact load of the network itself is very difficult. But predicting some upper bound and lower bound is way easier and actually doable. So with a very good quality, one can do that. And this is essential for being able to do this basically optimization. So you know in advance that, I don't know, in a few seconds or I don't know, some hundreds milliseconds, there would be a big demand on the traffic. So you switch on the element in advance so that be ready in time. But also we have used digital twin for doing the prediction. So here, this is an output of a project that was concluded a few months back. Here we are talking about digital twin of connected mobility. It is in a campus network. There are so many, some vehicles moving around. And basically the idea is to predict when there would be a congestion in the network. So in advance, you see that, okay, in a few seconds, because of the mobility of the vehicles, pedestrians, any other users in the network, there would be a congestion. So you predict, you see it in the digital twin, and then basically you take proactive measures. You might do some enforced traffic steering. You might be able to reroute some of the vehicles in order to avoid such a such a congestion scenario. So basically, digital twin can also be used as a tool for predicting the future of the network status. We have also done some studies on how to use or how to optimize the network component and activation of them based on the prediction that we have about the network. So if for instance, we know that, okay, there is certain delay in terms of waking up time of the component, how should I switch off and on elements in advance using the prediction algorithms that I do have to be able to serve them? And of course, you need to be a little bit over-allocating the elements. But if one does the optimization in a good manner, then the over-allocation would be minimal. So there is a big potential to save energy consumption. And as another example for this digital twin activity, so this ORAN digital activity, with some partners, we basically developed this X-app, R-app energy saving tandem, where the R-app basically does the policy, determines the policy in terms of like when we should do the switching off and on, and then the X-app is used for monitoring and also as an execution layer. So like really do the job. And then it turns out that, as it is also known, that in the low traffic scenarios, one can save a big basically amount or percentage of energy consumption because the network is underutilized. All right. Okay, so this brings me to the last slide for basically conclusion. What I wanted to basically mention and point out in this talk was the need for overarching approach, right? We cannot just look at one aspect of the problem. We are dealing with very complex models. That's why we also would like to use digital twin as a tool, but also there is the variety of components with different consumption models that needs to be taken into account. And here, what is really needed is more and more energy consumption measurements in order to be able to characterize the model. And then when we have the model and when we have proper traffic predictions, then we can also run and apply some energy saving algorithms in order to make the whole, let's say, system more energy efficient and sustainable. Last but not least, there is this aspect of battery powered devices in the uplink. So this is, of course, I didn't cover it in this talk, but this is also what we are currently investigating, that many of these methodologies and decisions might lead to against basically the channel quality for the users which are on the battery. And this can, of course, drain their battery very fast, and like you will end up with a very bad quality of experience. So that this needs also be taken into account in this system of system approach. With that, I would like to and conclude my talk. Thank you very much for your attention. Would be happy to answer your questions.
Once again, so the Q&A section will be hosted by Ray maybe 20 minutes later. So please wait online for a while. And thanks for insightful presentation. And now let's welcome Abdel from TIP to share their strategy for testing in Beijing. Abdel, now the floor is yours. Thank you. Hi, Abdel. You didn't turn on your mic. We didn't hear you.
Oh, sorry. Apologies.
Oh, that's okay. That's okay.
I hope you can hear me now.
The floor is yours.
Thank you. Thanks. I was saying that this goes in well after what Charles have mentioned and Ihsan on energy efficiencies and the R apps and the X apps that are being tested in Sonic Lab. So what we are trying to achieve in the Telecom Infra project is how to take those applications from the umbrella of research and development and take it a step closer towards MNOs networks to be within a commercial environment. So, and this is the essence of what we're trying to achieve. I'm Abdul Bagegni. I head the Open RAN project group technology within the Telecom Infra project. And for those who do not know much about the Telecom Infra project, we are a industrial organization, non-profit, based in the US, with the sole objective of bringing the community together to accelerate the disaggregation components of solutions. So the purpose of the Telecom Infra project, it has different project groups. The Open RAN project group is the project group that I lead, and the purpose of that is to accelerate the deployment of Open RAN solutions. And those Open RAN solutions, we try to make sure that these could be deployed in a carrier grade, I would say, and not limited to macro, but it could include private networks and enterprises, etc. The way we do that is by harmonizing the requirements initially, so bringing different players within the industry from different regions and setting a baseline of requirements so that the operators or those who would adopt these solutions can agree on this baseline. And we tend to kind of think that those requirements usually would be around 60 to 80% common amongst different regions. So if there's within the TIPS community, we have operators across the globe, and I think this is a fair number. So what we or a fair percentage. What we try to achieve is to make sure that those 60 or 70% of common requirements do reflect what the operators want. After those requirements are harmonized, then we start building up the architecture, which we call the blueprint. And then based on the architecture, we would develop the test plan associated with this specific architecture and the requirements. And then we define a success criteria that the operators who agreed on those requirements would accept within their networks. And then we go for testing, and we have the TIPS framework or badging framework. And then the other area is the RIC platform and the innovation in that space, including the service management and orchestration layer. Now, before I would say in the last couple of years, 2 to 3 years, the focus within TIP was mainly on end-to-end solutions on Open RAN, so bringing multi-vendors solutions together and start testing or creating the deliverables for testing. So we would create the test plans, the success criteria, the blueprint, the architecture, and then our coordination with labs such as the Sonic Lab and I14Y and others, these then can execute the actual testings. Now we kind of added another layer to this, which is the focus on the SMO and the applications on the RAN intelligence controller. And what we did is we restructured the project groups to have the solution subgroup, which would take care of the end-to-end performance testing, and these performance testings can be on different architectures like small cells or private networks, and it could include domain testings as well, like the open fronthaul or specific RAN features. But then we have the RAN intelligence and automation subgroup, and the main purpose of the RAN intelligence and automation subgroup is exactly to leverage the machine learning and the AI elements of the XApps and the RApps and take it to test and make sure that we can take this towards a closer, a step, as I said, closer to become commercially deployable in a MNO's network. Over the years, we've created 16 use cases from traffic steering to uplink channel estimation. We have the RAN slice SLA assurance and a few others, including the coverage and capacity optimization. Now, the current project group within TIP has 5 co-chairs from AT&T, TELUS, Dutch Telecom, Vodafone, and Boost Mobile. And then each subgroup has its own leadership team. So there's a wide representation from different operators, vendors, and test and equipment suppliers. On the RIA subgroup, the RAN Intelligence and Automation, and at the same time, on the Solution subgroup, we have representation from 6 companies, including from operators and from vendors. Okay, but then the role of the community to accelerate the RIC and the SMO, because over the last couple of years, as I've mentioned, we executed a lot of these use cases in a lab environment. But we can say that everything we actually tested were based on research and development. There's a lot of emulators and simulations in it, and it doesn't reflect. Let's say that there's still a gap between what is tested in these labs and to have those applications in an operator's network. One of the projects that we kind of worked on in the last year or so was the what we call the Ariane project. The Ariane project is funded by the UK government, and it includes around 10 partners. And the idea for that is that we took 3 use cases. So we have quality of service-based resource optimization that was designed and developed by Reply UK. And then we have advanced traffic steerings that was developed by HCL and Reply. And then we have energy savings that was Amdocs and Reply. And that was deployed in a lab environment with a VMware near real-time RIC and a non-real-time RIC with the Anavayavi RIC sandbox. And this has concluded last year, and then now we've upgraded this project to include some over-the-air testing with our partners in Sonic Lab, and this project is still ongoing. So what happened on those projects is that we did show how these applications, the R apps and the X apps, can actually be deployed in a commercial network, or not in a controlled network. But at the same time, there's still that gap that I've mentioned, and hence what we did earlier this year, we thought of how can we transition those applications into a deliverable that operators would understand the value out of this. So, for instance, there's non-real-time RICs, like say within the industry, and third-party applications are saying that they've successfully integrated with those non-real-time RICs. So, as an example, we have the Ericsson's EIAP platform. If you go to Ericsson's EIAP platform website, you would find around 60 applications from 40 different vendors mentioning that they've integrated with the EIAP. But when you ask the operators, what does that mean to them? There's no answer, because there's no baseline or specifications or system performance aspects that the operators can say, yes, these are the benchmarks or specifications that we said we want, and those applications actually do fulfill these requirements. So what we're trying to achieve at the moment within TIP and the RIA subgroup is to create a trusted path on the SMO, mainly on the non-real-time RIC. So the focus is on the R apps at the moment, given that this is the direction of the industry where it's going. And then once the outcome of these requirements that we've mentioned earlier and the baseline that is created, this then would reflect true value to the operators and say those actually use cases mean a lot to us because they have exhibited and shown that they achieve the performance criteria that we've set. So to start with the process, what we created 3 work streams. The first work stream is to start getting which use cases we want to focus on. At the moment, we had 16 use cases in the RIA subgroup, but then that is quite a broad use case. So we wanted to limit the use cases into a few use cases. And start gathering the requirements out of that. And then we went into the second work stream, which will then build on the test plans associated with those use cases and define the success criteria of these use cases. And then we go for the third work stream when it's testing and certification. So then those outputs of these testings then would reflect the true value of those R apps. So at the moment, the community is working on the first work stream. We've identified 3 use cases, and these use cases are commercially viable to a large number of operators within the next 12 months. The use cases that have been defined just a couple of weeks ago includes traffic steering, anomaly detection and root cause analysis, and geolocations. So these are the 3 use cases that we're focusing on at the moment. The use cases description has been updated, new requirements are being set, and now we're working on defining the requirements that are not related to a use case, which we call the SMO, RIC, and interface requirements. And what these means is how can we deploy an R app within a multi-vendor SMO on the R1 interface. So it's mainly driven on the R1, less so on the O1 because the O1 interface is not that mature within the ORAN. So we may accept some proprietary interfaces on gathering the, let's say, the KPMs or gathering any of the PMs or the CMs within the network. But the focus is on the R1, and we started to build those requirements on the SMO and RIC. The second work stream that, and this is due by the requirements, or the work stream 1 is due to be completed by the end of this, by mid-October. So the use cases should be concluded by the end of this month, and then the requirements should be concluded by mid-October. And then after that, we would take these 3 use cases and start developing the test plans and the test cases associated with these use cases that create a baseline and non-vendor specific. So we could get any developer, any R app developer who can develop and test against these this baseline, and at the same time there are going to be test cases that are not use case specific. So this should apply to any R app within the MNO's network, and this should conclude before the end of the year, and then we would be looking forward to start testing and lining up some non-real-time RIC platforms with our app developers towards testing the deliverables that are due to be out. So just to kind of wrap up what we discussed, so we spoke about the development and assessment framework of the SMO and RIC. This space is still kind of haven't been shaped yet, and what we're trying to do within TIP is trying to outline the strategic technical deployments of such SMO and hopefully assist and help operators to make decisions on how can they integrate our apps within their networks. we've defined the 3 streams of requirements, test plans, and testing and certification, and then this can be applied to TIPS badging framework. So it matters because this initiative kind of closed the gap between the R&D umbrella of those testings and taking it towards a MNO's commercial network. And then I would just like to conclude that this initiative is a community effort, and any vendor or operator who would like to join this project, they're welcome to join. They'll be working with the operators and the vendors to start defining the RIC and SMO and interface requirements and be part of developing the use cases and test plans. And with that, I conclude my presentation. Thank you all, and I'm happy to take any questions later.
Thank you, Abdel. Now let's welcome both Charles and Ethan come back, and also Ray to have our QA. So for domestic attendee, if you have any questions, please please raise your hand so that we can call you, and please have your question to talk to Charles, Abdel, and Ethan. Okay, we have Hafar. If I pronounce wrong, correct me. So we have Hafar online, and
yeah, very close. Yeah, it's my name is Jafar.
Sorry.
Hi, Abdel. Thanks you. I'll start actually with a question from your presentation. During the presentation, you referred to kind of badging and certification interchangeably. Do you do both in TIP or just one? Because if I remember well, initially TIP was focused on badging, testing and badging only, but I've seen you refer to the certification as well today.
Well, we call them badges. Yeah, to be precise, it is badging. And we have 3 tiers of badging, so bronze, silver, and gold. And yeah, it's badging. Please ignore the certification piece.
Okay, because look, I come from the ORAN background, so that's why I thought, because they have this differentiation between the two.
Absolutely, yeah.
Yeah, okay, thanks.
Okay, thank you. And we have Thomas, and please have your question.
Yes, hi, it's Thomas from Digital Catapult. I have a quick question to Abdel. Thanks for the presentation about this Open Running group. I think from my kind of interaction with this group, and also based on the kind of bigger picture, it seems that this group seems to be heavily driven by the large MNOs, operators, and hence all the requirements you said, okay, should be kind of like carrier grade and aligned with the industry. But I think there is a kind of need for capturing the requirements of like smaller operators, like a private network, enterprise type of networks within the whole framework of what you are doing, because maybe there is some need for maybe kind of like maybe relaxed requirements in terms of performance and for the devices and for the implementation, which could be potentially cheaper because of that. So do you have any view on that? Do you have like any plans in TIP to kind of support better this type of community? Thank you.
Yeah, thanks for the question, Thomas. And it is very, very relevant, because when it comes to the RIA subgroup, I think you're actually absolutely right. It is driven by the operators, but the reason for why it's driven by these tier 1 operators is because we are a community, and we kind of try to incentivize the industry to come forward and come up with ideas. And this is actually something that we initiated. We've brought the operators into one table, and we've discovered that discussed this gap within the industry. So that's on the RIA front. And obviously, as I've mentioned, this is coming from an R&D background, and we're trying to drive it towards a step closer towards an MNO's network. When it comes to the solutions subgroup, this is something that the co-chairs have already discussed, and I can say that the strategy of the solution subgroup will be out in the next maybe couple of weeks, and the in-building and small cells would be driven actually by cost. So the objective would be to reduce, and this is not final yet, but this is what the discussions are going towards, is to reduce the cost of small cells on Open RAN, on a multi-vendor Open RAN deployment, to match at least the incumbent solutions. So yes, and there's discussions on small cells. Do you actually even need a large list of alarming reporting? Maybe we don't need that. And there's a lot of discussions around that. But it needs to start from the top bottom. So we would need to start creating an architecture. What's the minimum viable requirements that needs to be in that blueprint? And then from there, I think we can take it forward.
Okay, thank you.
No worries. I have a question actually for Ehsan. I think I can ask.
Sure.
Right? Yeah. So you've mentioned a lot of interesting statistics and curves in your presentation. But when you modeled or put the models on the power or the energy versus load, and then you discussed the digital twin. How do you include the environmental factors on that? So because if you're in the lab and you'll be modeling the load versus energy, that's a constant kind of environment. But then if we go to the field, depending on the country's location, it could be quite warm. There could be humidity, even the pressure if it's in a high altitude location. How is that taken care of?
Yeah, thanks for the question. I mean, it's a still work in progress, right? So I don't claim that we have the ultimate solution right now, but yeah, as I pointed out, right? I mean, there is a big need for measurement, and this is what you're referring to, right? It means that we need to do these measurements under different circumstances, humidity, different temperature, different status of the network. So you're absolutely right. I mean, this can be playing a very big role. I mean, or might change the pattern completely. At the moment, we are doing measurements, of course, in the lab, but in the end, you need to understand how the model or how the energy consumption behavior varies in different environments. So we don't have so we understand that this is important, but we don't have the measurements yet, right? And essentially, yeah, you need to do it sufficiently in different types of environment in order to be able to generalize the model, right? In the end, and at least to cover, most important extreme cases as a factor of, this parameter that you mentioned, right? So in the end, if you don't have the right model, what we are optimizing is not really relevant. So yeah, it's really important. And that's also what we are trying to push is to, different entities, different labs start to share data, like I understand there is this data privacy issue, but there are also some ways to get away with that. So yeah, it can help, I think, the whole community.
Okay, thank you. I have a follow-up question on that. Sorry.
Sure.
When you mentioned the delay constraints on the wake-up time and the shutdown time of the power amplifiers, but then at the same time, the focus what you had is on the near real-time RIC. We see many of the energy use cases today are based on non-real-time RIC for different. For valid, I would say, reasons that we don't necessarily need to go into too much details. So if we would translate your activity into a non-real-time RIC, will this delay constraints become an important factor, or maybe it wouldn't be that important anymore?
No. Again, you are absolutely right. So I agree. I mean, well, in the end, it boils down to what is the required control, control loop time, right? So what is the difference between XAP and RAP from my point of view is the broadness or the amount of data that you have, right? I mean, how much of overview you have, but also like how fast you can react and make decisions, right? So I agree. I mean, in certain cases, I mean, at the moment we have been focusing more on the XApp just because we had the near real-time rig, implemented, and then it was easier. But actually, we are also collaborating with other entities also within the I14Y to use also our app, and also going to this direction of our app XApp tandem. Which means basically, to some extent you do things with our app, and then some parts are taken care by XApp. So it really boils down what you want to save. Like if you want to, for instance, save energy or switch off on things in millisecond, or I don't know, tens of millisecond order, then you need to use an XApp, right? But then if it is a more longer term thing, so I don't know, for the whole night I want to switch off something, so then of course an our app is sufficient, and also actually it's a better match because you have a better overview of the network and environment, right? I mean that area. So usually with the XApp you have more local let's say information. With the R app you make it a bit broader. So that's how we see it. So essentially it started just because we had a near real-time rig implementation, and with XApp activities was easier. But we are, at least conceptually, we are dealing with this, like how to do this 2-time scale or multi-time scale optimization. And then also now we are gradually getting into this kind of more our app basically development and so on. Yeah.
Thank you.
Thanks for the question.
Okay, I think because I see Charles, you have question, and I think because we have time limit, we still have 2 questions for this session. One question is for Charles, and I want to know Taiwan's audience, do you have any question for our foreign speakers? If you have a question, please raise your hand. Let me know. Okay. Charles, your time.
So I was just, not a question, I was just going to add on to the discussion regarding XApps and RApps. So we've noted exactly the same problem that you've highlighted, which is the XApps are very local and conduct very local operations in a very timely manner, but that means that they could conflict with one another because they have no context of what the other app is doing. Integrating the R app to that introduces policy aspects that actually can help with some of this mitigation. Abdel, you may be aware that in Ariane 2, we are doing the R apps development with some of the vendors that you had on your slides. So I would say the way forward is that there's got to be a merge between what the X apps are doing and what the R apps are doing to actually prevent this conflict long term. I can take my question now. I don't know what was the question was for me.
Thank you, Charles.
Okay, thank you, Charles. I think no question from Taiwan side. Okay, thank you for sorry, Shaffer, because we have a time limit, we don't have any more question. You can
that's okay,
email privately. Yes, thank you.
Okay, no problem.
Thank you for our foreign speaker Charles, Adele, and Ethan today. Give us a fruitful sharing for this workshop. And thank you. And we will go out to our next session is for Taiwan domestic partners sharing. Thank you. Go ahead, Simon.
Thank you all for your participation. 那接下来我们欢迎资策会的张仁伟资深分析师，那就 RIC 的平台发展现况与趋势分析为我们做分享。那麻烦您仁伟。
不好意思，等我一下，我分享一下。等一下，我分享我简报，等我一下，不好意思。请问看得到我的简报吗
？OK， 没问题，声音也很 OK。OK，
谢谢你啊，我要开始哈。那其实在这部分稍微跟大家做一些 稍微讨论跟稍微介绍一下目前我们在研究在全球 RIC 方面的一些进展跟一些我们的一些心得。那其实简单来说 ，RIC 我们都这简单讲个定义，是因为说我们想要在这边可能对一些过去比较没有接触过 RIC 的一些好朋友们或者一些先进们，稍微可以理解到说，在我们的 OpenRAN 里面，其实 RIC 比较像是就是一个大脑，或者说像是一个 OS， 它可以让各种的application 那种应用程式可以在上面去 run。那基本上呢，在5G 或6G 的时代，我们相信说，其实在无论是 long real time 就是或者 near real time 的2种不同的 RIC 方面，基本上它都会发挥它的效果。那特别是在一些资源调度，或者是在一些能源的一些控管方面，其实它都是一个关键的一个角色。那其实有时候我们用 RIC 在形容上的时候，是可能比较难去了解说它是到底怎么运作。其实我稍微去把 RIC 的其实 RIC 你可以思考，它是个 OS， 而且它是在跟我们的整个网络的 decision making 是有关系的。所以你可以看到说，在这个网络图里面，只要每一个网络的事件进来，它其实都是个 event。那 event 它都会让每一个圈里面的一些的一些数值会去做变动，代表说每次处理了一个事件，它可能会耗用了多少的资源，那会造成多少的成本。那在这里面可以看到，XAPP 它也不断的在里面去做一些应用，所以它的数量会不断累积。那这个模拟是我希望是可以去看得出来说，当我们今天要去看到不同的一个网络的绩效的时候，我们怎么样透过这样的模式去把它 modeling 起来。这是我们简单做的一个视觉化的一个呈现。好，那其实我们现在可以看得到，就是说，其实目前全世界其实大部分的电信营运商，他们对于整个operate 呢，其实它的推动脚步是并没有停下来的，只是说，其实，在5大洲里面，其实不同的电信商它的一个部件的一个速度跟策略呢是比较不一样的。那其实多数的电信营运商其实大部分都是进行所谓的小规模的测试，或者他可能签订一些 MOU。那有一些国家呢，它其实比如说像是在美国呢，它其实会有一些比较大规模部件。当然我们也很清楚，在前年的新闻里面，那个 AT&T 有提到说，他们可能就是会在美国会有部件，他会跟那个 Ericsson 合作，会在明年之前呢，会在美国部件大量的那个 OpenRAN 的一个设备。那其中他甚至宣称说，可能以后的行动网络的流量有70%就来自于那个就是 OpenRAN。那这个其实都是一个。我们可以发现说，其实这个脚步并没有停下来，那全世界也正在不断的推进中。那当然，如果用另外一个维度来看，用时间的维度来看，其实更多的电信商在这场竞赛里面，其实是前仆后继的不断的投入哈。我们可以看到，从2022年，其实可以看到，无论在北美或者在欧洲，或是在那个不好意思，我的好像跳掉了，不好意思，抱歉，好像跳掉，抱歉。请问一下，有恢复到简报吗？不好意思，有哈，不好意思，那可以看到，其实在无论在北美洲里面，其实它的大部分的电信营运商，它是属于重度的投资的，而且他们是很早就进入到商用化初期商用化的阶段。那在欧洲的这些电信营运商里面，其实他们大部分都是小规模测试，但是比如说像 Vodafone 啊，或者 Orange 啊，这些它可能会有一个比较积极、比较大型的一些测试。当然，他们可能相对来说，他们资源是相对较多的。那在亚洲部分，其实我们可以发现有趣，其实日本呢是最早的一个投入到这些的部件里面，比如说像那个 Rakuten 或是 Docomo 这些大厂商。那当然这些厂商都还没到真正的商转的应用，可能都还是在初期的一些初期商用，或是甚至只是在测试部件而已。但是无论如何，其实我们发现，其实这是一个全球化的一个动作，就是无论在北美，无论在欧洲或者在亚洲，其实大家都是努力的在推动着。那其实更具体来看呢，其实可以看到说，像 AT&T 跟 Verizon 跟 Box Mobile， 其实他们都已经有立下说他们未来要怎么样去推这个 OpenRAN 的一个目标。那比较值得注意的是，其实像在欧洲，像Vodafone他有提到说他30%在欧盟的一个 的那个它的那个基站的那个流量是要透过那个 Open RAN。那其实我们都所知道，其实在英国政府其实他们曾经提出说是 Open RAN 的一个政策，就是说他们希望可以在2030之前的30%的流量，35%的流量是透过那个 Open RAN 的设备。所以基本上，无论在国家政策，无论在厂商的策略里面，其实在欧洲方部件的策略也是跟它的速度来说也是相当的快。那亚洲来看，现在除了 Docomo 跟 Rakuten 之外呢，其实像越南的 Viettel， 其实它也是有很积极的脚步在进行的这样的一个推动。那当我们也必须要了解到一个现实，就是即使现在 Open RAN 厂商他们这么努力，想要以设备商或是以运营商的角度来看的话，其实是不太一样的，因为其实以设备商来，如果我们把它刚刚都在讲营运商、电信运营商，如果切换到设备商的角度来看的话，其实全世界的设备运营商里面呢，其实95%是聚集在前几大巨头，比如说像是华为、Ericsson、Nokia 跟 GTE 跟三星这些大巨头。那我们看到的 Open RAN 的一个重要的一些非常 active 的厂商，比如说像 NEC、富基子，或是 Mamnia， 或是像 ASBand 这些公司，其实他们加起来占不到5%而已。那所以基本上，虽然他们很积极要推动，但是他们毕竟动能是相对较弱的，因为毕竟根据我们现在看的新的资料里面，其实前3大的市占份额又在2050又更大了，所以这其实是一个很比较尴尬的一个局面。那当然，另外一个角度是说，其实真正的推手应该是电信运营商，但是电信运营商其实它是一个比较重视就是投资报酬率的一个产业，也就是说它的。以研发投入来说好了，就是以电信运营商在北美的电信运营商或者一般的电信运营商来说，它的每年在网通的研发投资的成本大概是只有大概1到2% 而已。如果以我们看到那个在那个 ODI 数据大概是2%，可是如果说像是今天我们看到，比如说像你看到 NVIDIA、Intel 这些大 IT 公司，他们在投资在 R&D 上面可能是10%到20%，所以差距大概就是有10倍左右的差异，所以基本上电信运营商如果他们在投资上面是比较相对保守的话，其实对这个整个 Open RAN 的部件的速度是会有一个很大的一个影响。那举个例子来说好，我们看3大电信商可以看到，他们2023、2024到2025的投资基本上都是你可以看到都非常缓步的一个增加，比如说举例子来说，像 T-Mobile 从9.8就是98亿，那它可能到2025的时候，就是慢慢增到95，其实就是稍微推到95亿。那 AT&T 从178.5亿，那可能到2025的时候，它可能就是接近220亿。就是说，其实它是有的，就 AT&T 稍微成长，可是像 Verizon 你看它是187亿，然后在2025年的时候，它到185亿，所以说基本上它反而都是保守，或者是说稍微退，就符合刚所说，他们其实在整个设备的投资的 R&D 上面大概走1到2%的一个成长的一个空间而已，所以这个是一个市场的一个现实。好，那如果以制造商的角度来说，其实刚刚我说了，就是前3大的制造商基本上他们是占的整个市场份额非常大。那以目前来说，以全球来说，当然华为它的 revenue 可能还是算是数1数2的。那如果说在中国以外的地方，毕竟华为有被限制住嘛，所以它其实 Ericsson 跟 Nokia 还是占的数1数2。那特别来说是以 VRAM 的话，其实我们现在看到，其实以DL 的资料来看，其实 Samsung 还是在 VRAM 里面还是独占鳌头哈。那我这边会稍微提到说，现在其实大家很重视到所谓的那个 OPEX 的一个，就是说电信运营商希望可能够降低 OPEX， 所以他希望可以有更多的机会可以透过 AI 或者透过一些自动化的方式来改善它的一个运营，所以其实对 RIC 来说是相当的一个好的。那其实这个里面的成本里面最多的成本就来自于能源的消耗，所以电信运营商都希望说可以透过 AI 来降低那个能源的消耗。那这个里面你可以看到，如果一般的能源消耗里面的话 ，RAN 的消耗的比重大概是70到80%，它是最重的哈。那传输的话大概走10到15%，那核网部分其实走5到10%。所以如果你是一个电信运营商的话，你可能会最 期待能够去减低能源消耗，一定是放在 RAN 上面。所以这也你可以证实说，其实如果以 Open RAN 现在的一个方向，其实它是在 RAN 方面的一些进步，在节能方面的一个进步，其实会蛮符合现在电信银行他们期待的一些方向哦。那这边稍微一下可以更进一步可以看到，现在在放在 RIC 的研发里面，其实大部分的公司都有在做，但是其实市场上有一些变化，跟各位报告一下。因为其实像保姆尼尔，他最近因为财务上的一些重整，那他财务上重整有一些原因，第一个是他这几年的在 RAN 的营收，硬体方面制造营收一直在亏损。那其实它的软体跟 AI 方面的收入部门是不断的增加，所以保姆尼尔他在可能在 RIC 方面的研发，可能后续会慢慢转型在跟 AI 有关的一些研发的专案，所以它这部分就有点调整。那 VMware 的话，因为它已经跟那个 Qualcomm 被 Qualcomm 收购了，所以现在 Qualcomm 希望它去做 AI 相关的一些软体，所以基本上它也慢慢的推出这个市场。所以我们看到有两个很 key 的角色，一个 Mamlia， 一个 VMware 在 RIC 方面其实稍微慢慢变得比较没有那么强势。那但是像其他公司像 Ericsson、Nokia 跟中兴这些公司，其实都还是有在 RIC 方面发展，尤其特别是像我们可以发现比较有趣，像是那个像其实，在三星，它其实在这次的 MWC 的时候，它其实跟那个 Verizon 跟那个 Qualcomm 他们一起有展出一个 Qualcomm 的 RIC 叫做 Snapdragon。那其实 Qualcomm 它也开始做 RIC， 那这个因为就是它获得了 Verizon 的一个投入，因为 Verizon 希望可以跟全世界的不同的厂商去做一个就是混合战队，所以他希望可以把 Verizon 他希望可以把Samsung跟 Qualcomm 把它一起把它组起来。所以那Samsung因为他自己通常他是在 RAN 端的部分，他其实有一些能力。那当然他有一些节能的一个 APP。但是在 RIC 方面，他希望借重 Qualcomm 在这方面的一个经验，所以双方就有一些合作这样子。目前看起来是这样子。那这边有举个例子其实像今年其实 Rakuten 新闻蛮多，就是说他们其实透过就是在他们的那个Open RAN 的一个解决方案，希望可以去降低的那个能源消耗，至少达到20%以上的能源消耗。那这次他们在6月的新闻里面可以看到，他们在日本的本土里面，他们透过了 multi-vendor 的就是多个电信运营商的合作了，他们同时在日本的本土推动那个整个 RIC 的一个运作那他们其实实测起来，其实他们说应该是超过20%以上的能源的一个节省了，所以基本上这个代表说 RIC 其实已经非常的到商用的一个效益。那当然，它在它的供应链，大家可以看到它有找中联一起进来所以它其实这个大的部件，其实有时候对我们台厂来说其实是好事的，因为它其实会拉动整个的相关的一些供应链。那在这边有稍微举其他的例子，像 VMware 他直接提到说，他们用 IPP 可以降低25%的一个能源的消耗。那 Nokia 它是因为它有一个 Mata Bay 的一个 RIC， 那它有提到说他们也可以减低到30%的一个能源的消耗。那其实比较值得注意是，因为它这边的能源消耗它是搭配了它自己的 Massive MIMO 的一些产品所以在这一端其实你可以发现其实 Nokia 它还是会强调它硬体的一些优势，所以它 RIC 跟硬体的搭配，其实这是它的一个销售的一个重点。那这是刚刚有提到，就是在 Verizon 在 MWC 2025的时候，他有提到说他的跟那个 Qualcomm 的那个追根 Wing 跟那个神送的 AI ESM 的那个 system 的一个合作，他们就一起去降低了能源的一个消耗。那这个也是一个非常典型例子。现在的整个的 power 都集中在电信运营商手上，因为电信运营商他们手上有钱，而且他们有很大的一个推力。那同时他们也希望 multi-vendor 的一个那个模式能够在他们手中去做操弄，所以基本上现在我们可以发现这一个趋势，电信运营商他们占据的角色是越来越吃重。那这边有提到说，大概整个 Open Alliance 里面有3步说现在第一步就是要做一个就是透过基本的一个能源消耗的一个能源的一个节省的一个标准。那第2步骤就是希望可以把它用到 standards 里面去。那第3部分就是真正用 AI/ML 进去。但是其实因为现在其实有一些部分其实 我只能这样讲，说现在有些东西还没那么的完整，所以基本上还没到第3部分。我会估计现在还只有在第1阶段而已。那其实你必须这边最后再提一个，就是跟大家分享，就是说我们最近在看，其实要提到最近很红的一个关键字叫做那个 agentic AI。那 agentic AI 其实你如果仔细去想，它其实要做2件事情啊，就是去做到就是能够自我优化跟自我的修复。那其实自我优化跟自我修复这2个刚好是现在在提的 RIC autonomy、RIC 的自主权里面必须提到的东西啊。所以agentic AI 一定会成为 RIC 未来发展的一个重要的一个推手。但是光 agentic AI 并不够，它还需要3个重要的 element， 一个是就是所谓的 guardrail， 就是护栏，就是你在进行agentic AI 的时候，你就像小朋友在学走路一样，你有可能会犯错，你可能你 AI 的算法有可能会有错误，然后可能会超出你的那个 performance 指标。那时候你怎么样去定下指标的一个间距？那怎么样在它犯错的时候让它 backlog 或回复3.0版？这个其实就是很重要的一个设计。那第2个就是machine learning 的 operation， 就是说要把一些 machine learning 的机制也把它放进来，然后能够让它就是从过去的经验里面去做一些学习，那让它的一个整个模式，比如说在节能方面，它能够继续维持它节能的高效。那最后就是干净界面。那干净界面其实就是说，你 RIC 呢，你必须在所有的 RAN 或者 RAN 以外的所有的网通设备，它能够叫得动。比如说要有共同的标准、共同的规格，所以可能干净界面这个也会是一个重要的一个元件。所以我们可以观察到未来，如果说现在在发展 RIC 的厂商，他们这3步如果都做得好啊，我们相信未来的 RIC 呢，它不仅能够做决策，而且能够透过 AI 去做一个完全正确的一个决策。大概以上说明，谢谢大家。
感谢任伟的分享。那接下来呢，就麻烦易传的吴文灿董事长来我们分享他们易传的解决方案。Stewart， 再麻烦您。
来了。Can you see my screen now? Yeah, I think you should.
声音、荧幕都清楚，那就
Okay.
对。
Okay, let me put my slide. Should I want to redo? Okay, anyhow. So you can see the whole screen, right?
Yeah, full screen.
Okay, thank you for inviting me to join this nice conference. So what we're going to introduce is really what's Magnolia's role in terms of try to improve the Open RAN efficiency and the power. You guys all talk about really music to my ear. So my topic of the speak will be revolutionizing. We actually don't call 5G NEG ORU with a breakthrough the SDR SoC technology. 中文的话就是一传创新 ，OK。Okay, so you know that the global trend, traditional RAN, okay, just care about connectivity. Everything is static, and also mostly are very close. That's why all this system vendor controlling the cost of the deployment, and actually that's the main reason the 5G never been really deployed efficiently. So Ski accounts Open RAN for almost 10 years. But I think it's still moving slowly. But with lately all this coming, I think things will improve much faster. Especially with this, I don't really call AI for RAN. AI for RAN is really for a smart network, right? So because you can really try to handling all the AI inference, you can really care about the latency control, and also that you can really care about who you're going to connect to. What kind of deployment maximum you will be. So many things can be done. And just like Richard just talked about the autonomy, and it can be self-healing, self-maintenance. So will be becoming better and better network through time. Okay. So that's how I said the orange, and this is actually repeating what's been talked about earlier by those speakers. We talk about AI, we talk about machine learning, okay. But I think what is a fact to the to the network. And I think in the radio network, it's actually very, very important. This radio network needs to be very, very intelligent. So it needs to be consistently optimized, and its performance, its power, reliability, its security, okay, scalable. And so the key is really, I think at the end of the day, is really drive the economy of efficiency, reduce OPEX, right? Because we all need to know that OPEX is the key, because carrier need to make money. They really want to minimize their investment, but maximize their return, right? So our goal is really trying to be in that trend. So when we look at this issue on ORAN, the way we see it, yeah, you can have a CU inside the network, just like in base station within the carrier. So you care all this provisioning, care for all this SMP, care for all the security. You can have a DU like a DSLAM in the DSL market, but where's RU, right? And RU, what we have seen so far, all are very huge, power hungry, and very hard to deploy, okay? And also that people hesitate to deploy because, you know, not only that you deploy today, and then when you change the network, you have to upgrade. You know, today go to FR1, tomorrow FR2, and then B5G, and then 6G, or even more. I mean, how can we do that, especially with the line of sight of constraint? How can you deploy with some massive density? Okay, this is all other issue. We believe is all rely on solving the RU problem. This is actually repeating, right? When we look at all the issue, you can see that even 5G by itself, release 15, 16, 17, now we talk about 17, release 20. What they talk about it, you know, you cannot, I think a lot of people in the system vendor don't know. Okay, for example, today you use I don't want to name, you know, some people currently using mostly FPGA-based solution. And those FPGA-based solutions, if you want to make changes, you have to go ask the vendor, hey, I want to make a change, but the vendor may say, hey, I'm not up to change it until certain day. Okay, I see the full release. Okay, and then that's inhibit the IOP, inhibit all the deployment. Okay, because FPGA-based system, even though there's a few programmable, but you still need to recompile. You still need to recompile the ASIC, the FPGA. So it still take time to upgrade and take time to regression test. Okay, so we need to find a platform, which is SoC platform, which is one platform, and also with one software. Okay, who can do 5G, B5G, 6G. In my acronym, we call energy. So let me see. Here comes metanoia SDR, what we call SDR. Okay, if you really look at on the base, we have all this yellow part, brown part. It's all the hardware. Okay, this is actually SoC. Okay, so what we have a DAC, we have ADC, we have DSP processor, we have real-time OS CPU, we have network processor, and also we have a high-speed interface connecting to the front haul. Everything representing here is the programming part. That's the software. Okay, so where we have front haul transport from the wire side, so you get eCPRIT, you process the eCPRIT packet, okay, and they process through all the lo-fi. Okay, you have to do all this pre-coding, all this FFT, and then what's the most important in the front end? You need to take care of the DPD. Okay, and you need to do that very efficiently, and then you connect it to the analog RFIC over here. So when we imagine the metanoia, so we took an example of the 4T4R, 4 transmit, 4 receive ORU reference design. So this was the solution that we introduced about 2 years ago. Basically, you have a network processor with DFE, with 4 DFE, and then with RFIs, each one is for 2 channel. So this representing 44R. In a nutshell, within 2 years, we brought everything shrunk into one chip. Everything on the top, we shrunk as one chip. So this is actually very innovative, and we reduced the power, even though it's already much better than FPGA, but reduced the power further, another 75% to one chip. This system here on top, burning about 25 watt together. The chip below is burning only about 4 watt. Okay, of course, IFIC still remain the same. And the function remain the same, but actually more powerful. If you compare this to the power, this is about 3x the powerful than the previous system, but with much less cost and power. What we can in the Metanoia, what's the other thing we are very innovative is we really truly embrace open source. We are not like those big guys. They talk about open RAM, but they don't never give the partner or customer their source code. They always give my binary, so you work for them. In Metanoia, we work with our ODM OEM as a partner. So when we engage with our ODM OEM, we actually produce full source code. What we have the source code here, let me try to introduce here a little bit. This button is our firmware. It's tightly coupled with our hardware. This one is kernel, right? It's based on RISC-V. And then on top, we have application software. So this is, we provide M-Plan API, application programming interface. And this is all reference code. And customer can, based on this, to write their SMP, that write their provisioning. Okay, we have also S-Plan, M-Plan, CO-Plan. On the right-hand side, this blue side is our know-how, how we do the SDR. Okay, so when we call this Mozart, Metanoia Open Source Advanced Radio Technology. It's like CUDA to the G200. So this Mozart, so customer, but we are different. When big customer work with us, everything you see in green, we release in source code. Okay, we want to work hands in hand, partner. We want the de facto standard of the ORU. Okay, we also currently working with working group 7, white boxing the RU. So with that, we truly, my team member doesn't want me to use this name. We truly are the DSIC in the ORU. We reduce the power by 80%, reduce the BOM by 90%, not reduced by 10%, but reduced by so much. Okay, so make it truly deployable. Okay, with this on the right-hand side, it's actually 44R. It's no bigger than your home router at all. It's running 24 dBm. Okay, this is actually the board. This is the chip. Okay, and you can see the board is actually very small. It's 18 by 18 centimeter, and this have a powerful computing. Powerful computing core. It's RISC-V. The chip inside actually total 13 CPU, including RISC-V, including B20 DSP, including real-time OS, or merchant DSP, or merchant CPU core. That means we are really processor agnostic. Our platform is migratable, upgradable when we migrate to different process node. For example, today this is 12 nanometer. We move to 6 nanometer. We can move to 3 nanometer. Our architecture remain the same. Our software remain the same. So almost like you use your iPhone, you keep upgrading the hardware and software, but you're maintaining the same look and feel. Okay, and by doing so, okay, and we can reduce the heyday for the customer, reduce our support, and also eventually we're providing fastest time to market for our customer. I think this is real key to rolling out a new system. And on top of it, this is a fully flexible, fully programmable ORU platform. And when we do this RU, it's also very important that we maintain all the IOP. Okay, so this is actually showing you that we have been tested, including Intel FlexRAM, Octane for Marvell, okay, and NSP, NVIDIA, Okay, even OAI, okay, is fully operable. And this is actually showing you that we did the ARN test result. Okay, this is actually in the environment in the UK. So it's actually doing very, very well. So you can see that we have throughput of 1.5 gigabit per second. This is showing you another one. Okay, we are also doing in a lab for end-to-end ARN. So we use Metanoia ORU transmitting to a Samsung cell phone. Okay, and this is using 256 Quang. Okay, MCS 25. You can see that it's reaching 1 gigabit download and 100 upload. So what Metanoia really provided, we really have a world, even though we in Taiwan, but we really have a global presence, and also we have a global view to grow the company beyond Taiwan. And we are the only one, not just in Taiwan, in the world have this kind of SDR focusing on ORU. There's non-competitor in our field, which can be closer to what we can offer. So when anybody work with some Metanoia, very simple. We are one-stop shopping for ORU design. We provide SoC and RFIC with open source software, right? And this open source is not just kernel; it's actually semi-turnkey, okay? And also we provide the DVD programming for the customer. We also provide comprehensive factory testing tool. So that means that we thought about every step of the way for our customer when you want to deploy the ORU, okay? And so we finished almost all the work. So we lower the entry barrier for our customer to really use our Metanoia SoC to design the RU. It says all, right? The most cost-effective, flexible ORU device. And it can be scalable to NEG. And we have a massive ecosystem, eco-partner, as you can see here. Well, with that, okay, so I think ORAN is just about to happen. And Metanoia want to be the key enabler for this market. I welcome everybody to work with us and to make this happen. Thank you.
感谢 Stewart 的精彩分享。那接下来呢，我们邀请工研院的吴伟明工程师来分享 TIP 银白色项的更新部分。
好，
伟明交给你。
好
Thank you, Stewart.
有看到我的画面了吗？
有，那你的声音有点小，可能再调整一下音量，谢谢。
好，我大声一点。好，那因为时间不多，我简单介绍一下我们现在实验室做的今年度做的一些事情，跟国际实验室合作的项目，然后跟我们有一些已经参加完的，有一些是可能下个月会去参加的一些国际论坛的资讯分享，跟介绍我们台湾这边办的5G Summit的一个活动，简单跟大家介绍。好，那我们5G 开放网络验测平台呢，最主要还是希望可以去提升国内厂商的技术的成熟度，然后可以发展不同的 solution 到国际上面去使用。那最主要我们就是跟 TIP 合作，然后跟 ORAN 去追踪他们一些相关的规范。那以及跟国际实验室这边一起协助，然后一起成立一个共同测试的一个平台。那希望可以带国内的厂商去参加他们国外的一些验测活动这样子。那当然也包含到我们希望可以让国内的电信商也可以陆续的采用国内这些发展成熟的 solution 这样子。好，那这个就是讲到我们前2年如果因为其实也是蛮多熟悉的厂商参与今天的会议，所以这个是再简单跟大家说明可能比较新的一点的标章的制度啊。那目前的话TIP 已经 比较粗略的去分成2个 subgroup， 那这边就不细讲，因为时间不够多。那目前我们今年度也有协助一些厂商去申请标章这样子。好，那这边是我们跟4个国家的实验室，包含电信商有去做一些验测的活动跟一些计划书的整理跟讨论这样子。那主要是刚才其实我们有邀请到是 Sony Lab 跟 i40Y 嘛，那我们就是针对银牌的一些测试项目更新啊，然后还有节能基站的一些测试。那今年度我们就是有跟阳明交大还有体积去做一些这些节能应用的测试这样子。好，那这边因为时间不多，我就不细讲。那主要是想跟大家讲，我们今年度做的这个更新，其实是摆前几年我们有做一些，有些厂商已经通过了一些银牌测试。那到今年度，我们希望增加一些新的测试项目，然后来去更完整的验证厂商的产品这样子。所以我们大概已经花了将近1年的时间去跟国际的实验室，还有跟 TIP 去讨论我们要新增哪些测试项目，包含我们去修改整个测试的架构。好，所以在新的测试项目里面呢，我们会新增了像 RIP 的一些测试项目，然后包含到不同的solution、不同的 RU 的架构，接不同数量 RU 去做一些测试，也包含到说我们可能会有像E-Plane 啊这种能耗测试，那包含到可能多 UE 的模拟测试，这些都是我们新增的一些重点。好，那目前的话，这个更新的测试计划书已经在 TIP 已经提交给 TIP， 那我们已经有2次的会议。那这些参与会议的，就像一些国际电信商，他们是作为这个 subgroup 的一些代表啊。那像 AT&T 啊、Vodafone 或是像福奇数，他们都是这些这个 group 的 leader 这样子。那他们已经有提供一些他们希望可以加入的一些内容跟希望我们修改的目标。那这些都是我们还在讨论更新的方向。好，那到这个国际论坛分享的部分，就是大概两个礼拜前呢，我们实验室的成员有去德国参与他们筹备的 Summit 的活动这样子。好，那这个是印尼的这个电信交流盛会，那就是下周也是由我们实验室的成员会到印尼去参与，那也会做一些简单的议题分享这样子。好，那接下来这个是我们台湾筹备的5G Summit 活动，那可能前2年可能有一些厂商已经有参与过，那今年的话会在10月20到23，那如果就是那因为现在已经有邀请到一些国际的实验室，包含电信商参与，有这张投影片上面其实列了蛮多我们已经邀请到的一些厂商这样子。那如果还有台湾的厂商们，你们想要参与，然后还没有很清楚这些资讯的话，可以在这边下方这个联系资讯可以联络我们 Simon 或是娜这样子。那我分享到这边，谢谢。
谢谢伟明的分享。那我们接下来呢，邀请秀荣针对大基站大规模模拟基站节能检测及实验室一致性测试做一个分享。那秀荣，接下来麻烦你。
好的，大家好，那请等我一下，我分享一下我的画面。请问看到我的画面吗？
声音、影像都很清楚，简报很清楚。
好，谢谢。那各位先进好，我是秀荣。那今天很荣幸向各位介绍工研院与德国 i40Y Lab 共同合作的专案，也就是大规模模拟基地台的节能验测规划，还有实验室一致性的测试。那其实在这个专案中，我们是聚焦于 TIP 国际组织的 RIC 的节能的专案。那目标是希望透过验测 RIC 的架构下的节能 RF， 然后是否能够在不同的实验室与不同的环境中能够稳定实现节能这个动作，然后保持网络服务的品质。所以我们在这个专案中的目标就是希望可以建立一致且可以重现的测试方法。 那希望可以透过这样子的重现方法，然后去得到一个可以比较的结果。所以我们在这次 i4TY Lab 在今年2025 MWC 就有秀出这张简报，然后叙说我们共同一起做的事情，包含第一件事情就是我们共同去规划了测试的计划的测试计划书，然后第二件事情是透过统一的测试计划书的内容，然后去建置相关的测试环境以及一致性的流程。那第三个就是开始会进行实验室 IF 的测试，然后去观察节能的效果，以及最后会去比对双方的测试的结果是否一致。那所以在这一页最主要就是要去跟各位分享我们今年与 i4TY Lab 合作到目前为止的最主要4项的具体的成果。那第一项可以看到说最左边的这个 tip 的 test plan， 就是我们其实这份计划书不只跟 i4TY Lab 合作，还有跟德国电信、中华电信、Fraunhofer、HHI 还有 ENDC 各个 partner 一起共同完成这份测试计划书，并且也贡献至 tip 去做审查。那在中间这个就是这个审查过后，我们也会持续的参与 tip 的每个月的社群会议，然后去回报进展，并且去接受来自于国际的伙伴的回馈。那其实这些国际伙伴就包含一些重要的电信商，包含 AT&T、Vodafone 跟加拿大电信商 Telus。那因此各个电信商或是各个伙伴们就会针对于我们所量测的功耗的方法，或是流量模型或 KPI 的定义，然后去同步，然后去让这些参数是各个实验室都是愿意参考以及采用的。那第三件事情，其实在执行面上，我们今年有去建置了更大规模的场景，也就是说，我们是使用了 VIB TeraVM 这个 RIG 模拟器，然后去模拟大规模的基地台的数量以及用户的网络使用情形。因此，我们将这些拓扑还有流量的模型跟 i4TY Lab 的环境去做对齐，使双边都可以有完全相同的测试下，然后有相同的公信力。那在最后的话，其实我们有提到我们的基地台还有用户都是用模拟器去模拟出来的，但是其实在模拟节能的策略过程中，其实也是需要去了解实际的基地台的设备的能耗的状况是如何。所以其实我们也有在实验室去建置一套符合国际标准的5G基地台能耗的量测实验，然后针对于大型跟小型的基地台进行长时间稳定的功耗记录，还有设备行为的模拟。那这套系统也包含功率的量测仪，然后还有相关的数据，然后去反映真实运作下的一些功耗的表现。那所以就是简单说明，就是我们的 test scope 其实就是有分为2块。那第一块就是2个基地台，那这个2个基地台最主要就是验证 IF 的节能的功耗。那第二个就是我们有去建置一个大型规模的，也就是说有52个基地台，然后是城市级的场景。因此在这城市级场景就有包含了办公区、商业区还有住宅区。那我们会模拟800个用户在彼此的状况底下，然后去做移动或是网络流量的使用。那并且我们还会去设计每个区域对应的24小时的流量，还有用户的使用模型，然后去验证这些 IF 是否从小型的环境是否可以扩展到真实的网络，然后可以并且维持节能还有服务品质。好，那因为时间关系，我们就略过。所以我们在完成了测试计划和流量定义后，我们下一步就是要去进行实际实验室的测试架构。所以这就是我们的测试架构。左边是我们工研院的架构，右边是我们 i4TY Lab。那可以看到说，我们就是会同步一起去建置 RIG 平台。那我们使用的是 OSC， 那 i4TY 合作是 Juniper 的 RIG 平台。那我们就要去对接一个 Energy Saving 的 IF。然后要去测试他们的节能的状况。那我们对接的模拟器都是一致的，都是使用 VIB 的 RIG test。那所以其实最后刚才上一位讲者也有讲到，我们这次的这个成果也有在这个 i4TY Lab 的3密中去做呈现，然后去说明说，其实我们在无论是 这个大规模的流量的建制底下，然后获得不错的一个结果。那其实我们未来也会持续去深化这个合作，然后希望可以推广到更多应用的情景。例如，我们会希望说，这个节能策略是否可以下一步去连接实际的基地台，然后去得到完整的成效。那也希望可以透过各位交流，然后去吸收更永续的5G 网络。谢谢大家。
感谢秀荣的分享。那我们接下来呢，今天的各个历程的分享都已经结束了，最后的部分就是 Q&A 的部分。那我们把时间交给瑞燕。
好，那谢谢大家今天的参与。那我们也 speaker 也带来了精彩的这些演讲。那现在我们可以开放一些时间，看大家有没有什么样的问题问我们的 speaker， 或对我们实验室这边的有没有任何的希望有给一些建议呢？有的话，再麻烦举下手让我知道一下。有吗？请问大家有任何的问题要跟 speaker 请教吗？好，我看起来应该是没有人举手哦。好，那没关系，就是说，会后哈，我们也很欢迎，就是说大家跟我们实验室这边交流。那对于其实我们每年4月跟9月，我们都会举办像这样的活动。那另外，因为我们也跟国际这边有很多的对接的管道，像刚刚我们讲4国验测平台，然后明年其实我们跟在 Orange Alliance 底下就是说我们这边接下来会有一个跟电信商的一个测试的一些活动那这部分我们也都很欢迎到时候我们可以跟厂商联络进行一些交流合作那以上那这是我的 mail 在这边有兴趣有问题的可以再跟我联络，谢谢大家。那今天会议到这里，谢谢。
谢谢大家。